Principles of concurrency. Concurrency is the interleaving of processes in time to give the appearance of simultaneous execution. So it is the interleaving of processes in such a way that we think that the two processes, process 1 and process 2, are occurring simultaneously together. And I say simultaneous execution, which is a together execution. This differs from parallelism, which offers genuine simultaneous execution. However, the issues and difficulties raised by the two overlap to a large extent. Sharing global resources safely is difficult. So when two of them they overlap, P1 and P2, if they are executed together, then they will be overlapping each other. So when P1 and P2 will overlap each other, what will happen? There will be a global resource sharing will be difficult. Optimal allocation of resources is difficult. That means how much resources to be allocated to P1 process, how much resources to be allocated to P2 process. It will be difficult to understand. Locating programming errors can be difficult. P1 has made an error or P2 has made an error. It is difficult to understand because the context in which errors occur cannot always be reproduced easily. So there are three problems. Sharing of global resources is difficult. Optimal allocation of resources, how much ever resources are needed for P2 and how much are needed for P1, it will be difficult to understand. Locating programming errors can be difficult because the context in which the errors occur cannot be reproduced easily. Parallelism also introduces the issue that different processors may run at different speeds, but again this problem is mirrored in concurrency because different processes progress at different rates. So for example, what should be the value of the counter? Now there is a register 6 and there is a register 4. Now this is a process P1 and this is a process P2. These two processes are overlapping processes, and that's why it is difficult to understand the value of the counter. Because if the register 1 reaches first, then counter value will be taken up by same as that of register 1. If register 2 reaches first, then the counter will take the same value as in case of register 2. So now counter has taken the value 6, which means register 1 reached first. Register 1 reached first. For example, there are two girls. They have been told to write on a board. So this is the board. This is girl 1, this is girl 2. In this board, now between these two girls, the one who reaches first, so suppose the girl 1 reaches first, girl 2 is only over here by this time. The girl 1 will write on the board first. So if value printed is 5 by girl 1 and girl 2 was assigned a value say 3, so the counter value will become 5 because girl 1 reached first. So whoever will reach first, that value will come as the counter. So race condition. What is race condition? Which will run first? Which will go first? A race condition occurs when multiple processes or threads read and write data items so that the final result depends on the order of execution of instructions in the multiple processes. Two processes want to access shared memory at the same time. So process A and process B both want to execute the shared memory at the same time. Then race condition will occur. Who will go first and fetch the shared memory? Consider there are two processes P1 and P2 that share global variables A and B. Initial value A equal to 1, B equal to 2. P1 executes the assignment A is equal to A plus B. P2 executes the assignment B is equal to A plus B. What is the value of A and B if P1 executes first, and what is the value if P2 executes first? So this is what A is equal to A plus B, that is A is equal to 3 and here B is equal to 3. So if P1 will be executing the operation first, then value 3 will be printed, but that will be assigned to A. 3 is assigned to A. So rather than writing it A equal to 3, 3 is assigned to A. If P2 executes first, then 3 is assigned to B. This is the race condition. Who will be first executed and who will get the assignment of 3. So now in the next part we will see how do we avoid this race condition so that both of them get the value.